Welcome to Learn to Learn, and this is going to be episode one of our series on chemical engineering. Whether you're a brand new engineering student or just curious about how chemicals are turned into products, you're in the right place. In this episode, we'll take a look at what chemical engineers actually do and the types of variables we work with, and the essential tools we will use to start solving process problems. All right, so let's start with our course objectives. This will be what you'll learn in a typical introductory chemical engineering course. First, you'll build an engineering mindset. That means learning how to model real-world problems using equation, logic, and units. You'll also learn to perform material and energy balances, with and without chemical reactions. This is the foundation of nearly everything you'll do as a chemical engineer. And finally, you'll apply all of this to real chemical processes from fuel production and pharmaceuticals to food, plastics, and clean water. So let's start out with the first question. So what do chemical engineers actually do? Well, our job is to take raw materials like crude oil, natural gas, or even biomass and turn them into useful products through carefully designed processes. We don't just deal with the chemistry, we design systems that work safely, efficiently, and economically. That means we need to understand equipment, reactions, energy usage, separations, and control systems. All of this at once. In short, we scale up chemistry into real working process applications. Before we start talking about processes, we need to learn how we're going to describe them. We're going to use something called process variables. These are measurable quantities to define the system. Here are some of the most important ones. We're going to have temperature and pressure, which deals with how hot or compressed the system is. We're going to be dealing with flow rates, which is how much of a mass or volume is moving per unit of time. We're going to be dealing with a lot of compositions, which how much of a substance is present, which are often going to be found in mole percentages or mass percentages. We're going to be dealing with density and specific gravity, which is going to be how heavy a fluid is compared to water. We're going to see these over and over again, and it's crucial you're going to know the definitions of each variable. So one of the first tools that you're going to find in your chemical engineering toolbox is going to be dimensional analysis, often called the unity bracket method. You may have done a lot of this in chemistry, but we're going to go over it again. So let's say you need to convert 100 pounds of mass per hour into kilograms per second. You'd multiply by the conversion factors one at a time, making sure units cancel across the brackets. It's a methodical way to avoid mistakes and make sure your final answer is in the correct units. You're going to use this time and time again when you need to convert between SI units and engineering units. In chemical engineering, we're constantly switching between SI units and engineering units, like I said. Here's a quick comparison. Pressure can be in pascals or in atmospheres or even psi. Mass can be in kilograms or pounds. Flow rate might be in cubic meters per second or gallons per minute. You can find temperature in Celsius or Kelvin, but sometimes you may find it in Fahrenheit or Rankine. You'll need to be able to recognize and convert these quickly. And always make sure your final units make sense in your equations. It always helps to do a logical check at the end of your problems to make sure that your answer seems reasonable and correct. A process flow diagram is going to be one of our tools that we're going to use for the rest of our chemical engineering career. One of the first steps in solving any problem is going to be drawing a process flow diagram or flow chart. It helps you see what's going into the system, what's coming out, and what's happening on the inside. We're going to draw a boundary around our system, label your knowns and unknowns. This is going to be where our process variables come into play. We're going to show each stream with direction and flow rate. Whether you're solving a simple mixing problem or designing a reactor network, every solution starts with a clear diagram and clear process variables. In the next episode, we're going to start solving our first real engineering problems using the general mass balance equation. We're going to talk about steady versus unsteady systems and how to build equations based on the flowchart. This is where the fun really begins, and where you're going to really start thinking like a chemical engineer. Once again, thanks for watching Wired to Learn, and don't forget to subscribe if you're going to follow this course series. See you on the next one.